So you've probably sometime shocked yourself by probably accident. And what happened here is that some electrons um, happen to want to jump onto you in order to conserve charge. So today we're going to go over electrostatics and circuits, which basically electricity can be made from. So what is charge? Well, charge is the fundamental force of an object when it's put into an electromagnetic field. It's often defined as Q, or in coulombs, which is the unit for charge. These usually come in nature in some form of elementary charge E, which is roughly about 1.6 times 10 to the negative 19 coulombs. And of course, as usual, opposites attract and same repels. And of course, charge conserves. So what is Coulombs Law? Coulombs Law is a law defining the magnitude of a force caused by electric charges. So basically the magnitude of electric force is equivalent to K, Coulomb's constant, times Q1, Q2, two different charges, and R squared, which R is the center to center distance, not the radius of the charge. And this is just defining the force's magnitude. So K is usually defined as 8.99 times 10 to the ninth. That has Coulomb's constant. And it is very, very similar to Newton's law of universal gravitation, except we have here, instead of big G, we have K, and Q1, Q2 are instead masses in the gravitation law. And things that you do to the distance in terms of the universal gravitation will be identical or nearly similar on the electrical side, but keep that in mind. This is also center to center distance. So this unit we will have a lot of stuff dealing with circuits. So what is a circuit? A circuit is just a simple closed loop in which an electric current can flow through. So a basic example is shown here, with here a voltage source, a battery, usually defined like this, and a current defined going this direction through a resistor, which is something that resists current. And we often usually denote the current direction from the long side or the positive side, although in theory it actually in real life comes from this direction, but you would get similar results doing the same calculation. What is resistance? Resistance is an element in a circuit which restricts or resists the flow of electric current. It's often defined as this symbol, which is some wavy lines next to two straight lines through a circuit. And resistance is measured in ohms and denoted as R in terms of circuits. And in this course, these can also be light bulbs with similar elements. So what is current? So electrical current is pretty much the flow of charge per second through something. It's usually measured in coulombs per second, or amperes, or amps, or A. And it's often denoted as I in terms of the circuit. So what is voltage? So voltage is the electric potential energy per charge. It's often defined as V, or joules per coulomb, or coulombs per newton, or newtons per coulomb, or as volts. So this is often sourced as a battery in a circuit and affected by resistance, especially internal resistance in a battery, but also is affected by current, which I did not put on here. So keep this in mind, this is actually not coulombs per newtons and newtons per coulomb, and that is through algebraic derivation. So combining the three terms together is the equation V equals IR, which is saying that voltage is equivalent to the effects of current and resistance. And if you need to solve for one or the other, you can just simply isolate this variable. What's the difference between series and parallel circuits? So, well, these are the two common types of circuits you will see in a common design. These will also be combined as well, so keep in mind to know how to differentiate it. So first, we need to look at series, which certain elements cannot be shorted, which means you can't skip the element necessarily, and charge must flow through all the elements. And then the current remains the same throughout in a series circuit, And to find the total resistance, we just sum every resistor together. Now in parallel, the elements can be sorted or skipped, and the voltage in each branch is the same while current is different throughout. And to find the total resistance here, we have to reciprocate the sum of all each branch reciprocated. So basically saying 1 over total resistance is equivalent to 1 over resistance 1 plus 1 over resistance 2, and so on and so forth. So here's electrical power. So this electrical power is very similar to the conservation of energy version of power. It can be achieved through algebraic manipulation. And of course, you can solve for it using P equals IV, or P equals V squared over R, or P equals I squared times R, which is pretty much through algebraic derivation. And you can express this as many forms, such as watts, and given a time period, you can do it in joules. And also you can do it in kilowatt hours, which is what often power companies use to figure out how to charge you for their services. So what are Kirchhoffs laws? So Kirchhoffs laws, the two Kirchhoffs laws you need to worry about in this class are Kirchhoffs junction rule, which is any charge coming out of a junction must equal to what goes in the junction, or this is specifically referring to current. So this is referring to conservation of charge. And Kirchhoffs loop rule, the sum of the total voltage through a loop is equivalent to 0. So then when you need to solve for unknown currents or unknown resistances, you can use that method to figure those out.